first lesson of the new year. It is a continuation, really, of working with proportional relationships and solving proportions for real-world situations. And this is a specific real-world type of problem, very common, that uses proportions, and that's using scale drawings and models. So a scale drawing or a scale model is used to represent something that is either too big or too small to actually show in actual size. Like a map is a scale drawing or a blueprint of a house or a building, or models of large things, buildings and things like that, or also models of small things like the model of a cell or an eyeball or something like that that's much larger than it is in real life. So we use these all the time in all kinds of applications. And every scale drawing or map has a scale. Okay, and the scale tells you the lengths in the map or the model compared with the actual real world length. The scale or the model drawing is always first. So you might have a model where 1 inch on the model corresponds with 3 feet in the real world actual object, or 1 centimeter. It's a model of something that's small. 1 centimeter is the scale of the actual 2 millimeter length. And lengths and widths are all proportional. So all measurements in scale models are in proportion. So suppose, here's an example, you have a dragonfly. The normal dragonfly has a 4 centimeter wing length. Okay, and then there's the actual, the model is 4 centimeters. The actual length of the insect's wing is 6 centimeters. So this is not a very significant use of a model. You kind of could be just doing a real world, sculpture of a dragonfly, I guess. But what is the scale of this model? Well, the scale, the model over actual. So we always use model over actual. And in a proportion, model over actual equals model over actual. And to find the scale, you want to know what one length in the model corresponds to in the real world. That will give you the scale 1 to whatever. 4 centimeters to 6 centimeters equals 1 centimeter to X centimeters. The unknown is the amount of centimeters in the actual thing that corresponds with 1 centimeter in the model. Okay, this is not a really very good example, not a very useful example, but it does show you how to do the problem. Where you cross multiply here, 4x equals 6, right? Cross multiplying 4x equals 6, and then divide by 4, so x equals 1.5. You could do this in your head too. 4/6 or 2/3 is 1 to 1.5. Okay, so the scale, the answer is 1 centimeter to 1.5 centimeters. You can write it as a ratio with a colon. You can do it as a fraction. Okay, it's common to do it with a colon. And really, we'll talk about this later, but when the units are the same, you don't even have to put the units in there. Okay, the scale is actually 1 to 1.5. Okay, which is actually a scale factor, which we'll talk about in a second. And again, another reason why this is not the best example. Not the best example to use in the book. These are better. Okay, because this model is obviously not going to be anywhere near the actual size of the World War II memorial in Washington, D.C. Okay, so it says the pillars of the actual memorial are 17 feet tall. Okay, and a scale model has pillars that are 5 inches tall. So what is the scale of the model? What is the scale of the model? So 1 inch on the model corresponds to what? Okay. So model over actual, 5 inches for over 17 feet. And it's kind of common to put the units in here when you're doing these kinds of problems. Over here, you could go inches over feet, but then it's better to kind of just think of this as the model over actual. Model over actual equals model over actual. So 5 inches over 17 feet equals 1 inch to X feet. Okay. And this one's not so easy to do in your head because 5/17 doesn't really isn't an easy fraction to simplify or do in your head. Okay, but you do know that it's divided by 5 here, so you could divide this by 5. That's what you're going to do eventually, because when you cross multiply, you get 5x equals 17. So divide by 5, 17 divided by 5 is 3.4. So that means that the scale is 1 inch to 3.4 feet. 1 inch to 3.4 feet is the scale. Must have the units in here when they are different. Okay, 1B. The model of a bridge is 16 inches. The actual length of the bridge is 50 yards. That is not the bridge shown here. The bridge shown here is much longer than 50 yards. It's the George Washington Bridge. But anyway, what is the scale of the model? So your proportion, model over actual equals model over actual. And that means 16 inches over 50 yards equals 1 inch to x yards. Cross multiply, 16x equals 50, or just divide 50 by 16. These problems, it's okay to just do that. And that comes out to 3.125. 3.125, or 3 1/8. 3.125 inches per yard, or 1 inch rather, is 3.125 yards. Right? The x here is the number of yards, so 1 inch is 3.125 yards, or 3 1/8 yards. All right, so as I mentioned earlier, scale drawings and models, if the scale measurement and the actual measurements are the same units, then the scale can be written without any units in there, and then it is called the scale factor. The scale factor is when the units are the same and it doesn't have any units. So if a model has a scale of 1 inch in the model is 2 feet in real life, okay, the actual scale factor for this, you have to make these the same units. So we convert feet to inches, that's 24 inches. So it's 1 inch to 24 inches, or 1 to 24. This would be the scale factor. Okay, the scale is 1 inch to 2 feet. That's a scale. Scale factor, 1 to 24. And you can use either one of these to calculate things, such as the blueprint of a skateboard ramp shows that its length is 11.4 inches. Okay, so here's a model of a skateboard ramp. And it's 11.4 inches long in the model. Okay. The scale of the blueprint is 1 inch is 6 feet. Then what is the length of the actual skateboard ramp? Now, this is a pretty easy problem. I wouldn't do this by solving a proportion, because if 1 inch is 6 feet and the model is 11.4 inches, then you just multiply 11.4 times 6, which is what ends up happening if you cross multiply here, and you get an answer of 68.4 feet. Okay, right? Because it's 11.4 inches, so they're missing the answer here because they show it later on. Okay, but we'll just put it in here. Okay, so 68.4 feet, 6 times 11.4. Now, this is certainly how I would do this problem. If they give you the scale and they give you the inches, they give you the model length, well, then you can easily calculate the length of the actual skateboard ramp. But they will go on now to show how to use the scale factor for this problem, which makes it way harder. So I don't know why you would do it, but this is the process. Okay. So if the scale is 1 inch to 6 feet, what is the scale factor? Well, the inches and the feet, these have to be the same units now. So you convert 6 feet to inches, multiply by 72, and you get 1 inch to 72 inches. Okay. So the inches now cancel out. You have no units now. And that means the scale of this drawing is 1 to 72. Okay, so the drawing is 1/72 size of the actual skateboard ramp. Okay, the actual length is 72 times the measurement on the model or on the blueprint. And you can use an equation here, okay, to find any length and actual of actual length, that it is 72 times the model length, no matter what the units are. Okay, so actual equals 72. I would use an M here, maybe, or they use B for blueprint. Okay, M for model, or D for drawing, or B for blueprint. And again, you get the same answer by multiplying 72 times 11.4, except now this answer comes out in inches, right? Because the 11.4 is in inches. So when you use the scale factor, whatever measurement you use for the model, that's units. That's the units of the answer. So 820.8 inches, not a very useful measurement. So you'd have to convert this to feet. So you divide this by 12, and then you get 68.4 feet again, same as you did with method 1, which is what I would use for this problem. I would simply multiply 11.4 times 6 because each inch in the model is 6 feet in the real world. All right, so I'll give you a problem here, and we'll see what the proper way to do this one. A map of a natural history museum shows that the dinosaur exhibit room is 7¼ inches wide, and the scale is 1 inch is 8 feet. So what is the width of the actual exhibit room? Well, again, I would just go, if each inch is 8 feet, then I would do 7.25 times 8, because the scale is 8 feet per inch, and get 58 feet. So that's one way to do it. Or you could set up a proportion, model over actual, 7.25 inches over x feet, because you don't know what the actual one is, equals 1 inch over 8 feet. And again, if you cross multiply, you get 7.25 times 8, 58 feet. There's no way I would do this problem using the scale factor, okay? Because that's going to require me to convert this 8 feet to inches. Okay, so it's 1 to 96 is the scale, and you multiply 7.25 times 96, and then after you do that, you have to divide by 12 anyway. So that is not the use of the scale factor, but we'll look at scale factor here a little bit more. Okay, so scale factor is a way to show the actual ratio of the size of the model to the actual, to the real life thing that it's modeling, okay? So every map or scale drawing or model has a scale, okay? And typically, in a lot of those applications, the scale is gonna have different units. So here's a drawing of the solar system, and it's 1 centimeter is 1 astronomical unit. An astronomical unit is the distance from the Earth to the sun. So you see here in this drawing that the distance from the Earth to the sun is 1 centimeter in the drawing, because that is 1 astronomical unit. That's the definition of an astronomical unit. Okay, so that's the scale. Scale factor has no units. Okay, so there's a picture here. There's a horse, and there's a picture of the horse, and the picture is 1/10 the size of the actual horse. The scale is 1 to 10. It shows here that the actual measurements of the horse in millimeters. Okay, so they actually measured it as like 1.5 meters and then 2 meters long. And then the drawing is 150 millimeters or 15 centimeters high and 20 centimeters long. Okay. But they use millimeters for all these. So this is a scale factor. It's not really the scale. This picture that I took called it the scale. Sometimes these words get interchanged, but it's a scale factor, 1 to 10. The scale factor has no units. So it doesn't matter what you put in here, inches to inches or centimeters to centimeters. Right? If there's 1 centimeter on the drawing, it'd be 10 centimeters on the actual horse. 1 inch on the drawing, 10 inches on the actual horse. Scale factor, it doesn't matter what units you use. All right, so what do you have to be able to do with this? Well, if you're given the scale, you could find the scale factor. We kind of looked at this before. So what is the scale factor for this drawing of the solar system? 1 centimeter, here's the scale of the drawing. It's shown on the drawing that 1 centimeter equals 1 astronomical unit. Okay. 1 astronomical unit is the distance from the Earth to the sun, which is 149 million, roughly 150 million kilometers. Okay. So how do I get the scale factor? Well, I have to have the same units. So if it's centimeters here, then I got to convert astronomical units to centimeters. What is the easiest way to do that? Maybe not the easiest way, but the best way to do it without messing up? That's right, dimensional analysis. I knew you were going to say that. So the scale is 1 astronomical unit is 1 centimeter. I probably could have done this the other way around, but I'll show you why I didn't do it the other way around as we go along here. Okay, so 1 astronomical unit to 1 centimeter, that's the scale I'm starting with, and I need to get centimeters on the top so that I have centimeters over centimeters, and I have the scale factor then that has no units at all. So I know that 149 million blah, blah, blah kilometers is 1 astronomical unit. I will round that to 150 million kilometers. Okay, 150 million kilometers per 1 astronomical unit. And again, this using dimensional analysis, right? The astronomical unit goes on the bottom so that these units cancel out. Now I need to get from kilometers to centimeters. I'm not going to go directly. I'll go to meters first. And I know that there are 1,000 meters in 1 kilometer. So that's a conversion factor to get rid of kilometers. And then there are 100 centimeters in a meter. So that's my last conversion here. Meters cancels out here with meters. And conveniently now, centimeters here cancels out with centimeters over here. So that gives me my scale factor. 150 million times 1,000 times 100. Well, that's going to be a 1 and a 5 and a bunch of zeros. So I'm going to do this in scientific notation. 1.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th. 1.5 times 10 to the 13th to 1. No units in there. It's 1.5 times 10 to the 13th inches per 1 inch. 1 inch on the drawing would be 1.5 times 10 to the 13th inches in real life. Okay. Not very useful to use a scale factor for things that are this big. Okay. But that's what the scale factor would be. And actually, this is not how you write the scale factor, right? The proper way to write it is always to have the model length first, 1, 2, 1.5 times 10 to the 13th. Am I writing in gray? Oh, because of this thing at the bottom. Okay. 1.5 times 10. This is the scale factor. 1 to 1.5 times 10 to the 13th. And again, no units because they're the same. All right, here's one that's a little more realistic. This model of a 377-foot long Virginia-class submarine is 34 inches long. Okay, so the model's 34 inches. The actual submarine is 377 feet. What is the scale factor? All right, so in order to get the scale factor, I have to have the same units. So how long is the submarine in inches? It's going to be 377 times 12, which is 4,524 inches. Okay, so it's 34 inches to 4,524 inches, like that. Okay, and if you divide this, 34 divided by 4524, you get 0.075154. Okay, this is not the scale, right? It's kind of backwards. Okay, the scale, or what this is as a fraction, is really what you're looking for. Okay, which is not so obvious when you look at this, right? What you could do is divide this backwards, right? If you did 4524 divided by 34, that will give you the actual how many inches the real submarine is to 1 inch on the model. Or you can do 1 divided by this decimal, 1 divided by this decimal to give you the same answer. And it comes out to about 133. Okay, so the scale is about 1 to 133. The other way to do this is with dimensional analysis. Kind of gets your divisions and multiplications straightened out. And if you do in dimensional analysis, if you do the larger measurement on the top and the smaller measurement on the bottom, then you'll get this 133 number at the end. Okay, 377 feet divided by 34 inches. That's the scale that we know. Okay, the scale with different units. Convert feet to inches by multiplying by 12. And then I get this. So then I get 37 times 12, and the inches cancel out and the feet cancel out. And I get 4524 inches divided by 34 inches, and that gives me directly 133 to 1, which means the scale is 1 to 133. That is the scale of the model. Models almost always use scale factors like that. Okay, I was looking on the Lee's Toy and Hobby website, right? They have lots of models there, and all of them show the scale factors of the model. You can get an MD-80, airplane, a 1 to 144, which is a fairly common model scale. Okay, 1 inch on the model is 144 inches in real life. A car model can be a little bit bigger. It's 1 to 24, this SUV. There's a glow-in-the-dark Bigfoot model. That'd be pretty exciting, 1 to 12. Okay, or something that's really much larger, and this model is going to be pretty small now because 1 inch on this model is 1,200 inches on the actual Titanic. Okay, but you can see that the scale factor is very common in models. If you're a model builder, you know scale factors. Some model trains are that way, all those kinds of things. All right, so for practice here, before we get to the next class where we'll do the problems in the book, there's a couple of IXL topics, and most of the work in these are talking about finding scales and scale factors. I only went through a couple of the problems, so I'm not sure what exactly kinds of problems you're going to see in here, right? But I did one from each lesson here. So 84H is word problems with scale drawings. Okay, so they'll give you Candace drew a drawing, and it's 14 feet in real life and 7 inches long in the drawing. What is the scale? So if they give you the actual and the model, dimensions, then you can figure out what the scale is of the drawing. Now, this one you should be able to do in your head. 7 inches in the drawing is 14 feet in real life. So 1 inch is going to correspond with, well, this inches is half of the feet. So that means that 1 inch is 2 feet. Okay. Now, if you can't figure it out in your head, which is all you have to do for these IXL things, you can always write the proportion. 7 inches, drawing over actual, 7 inches over 14 feet equals 1 inch over X feet. And then if you think about that or write this out, then it's a little more obvious. You can just simplify this fraction to 1/2, meaning that X is 2, and your answer there is 2 feet. So the scale that she was using is 1 inch to 2 feet. If they asked you for the scale factor on this, it would be 1 to 24, 1 inch to 24 inches. Okay, that's what's happening down here in the second one. So in Z9T, it's working with scale factors. Okay, so Kimmy drew a scale drawing of an apartment, and the living room, which is 10 meters long in real life, is 4 millimeters in the drawing. Wow, 4 millimeters in the drawing. That's like the width of the pencil eraser. Not even. Okay, that's a pretty small drawing. All right, but anyway, 10 meters in the room, 4 millimeters in the drawing. What is the scale factor? Remember, it's always model first, so it's 4 millimeters to 10 meters would be the scale, but they have to be the same. So I got to convert 10 meters into millimeters. Well, there's 1,000 millimeters in a meter, so that means this is 10,000 millimeters. 10 meters is 10,000 millimeters. Okay, if you don't know your metric conversions, you can look in the back of the book or online, obviously, that a millimeter is 1/1000th of a meter. Okay, well, this isn't the right answer, though, because this is not simplified. It is a scale factor, 4 to 10,000, but you can simplify this, okay? So divide it by 2, or divide both sides by 4 if you could, right? And divide it in half, that's what I would do. Divide it in half, that's 2 millimeters is 5,000, and divide in half again, 1 millimeter is 2,500. So the scale factor is, and it says to write it as a ratio using a colon. So the answer is 1 to 2,500. And that's what you would put in for your answer on that one.